Hey algebra students, this is our video on inequalities. We're going to cover writing, solving, and graphing inequalities all in one video. Because honestly guys, it's the same thing as equations, there's only a couple of differences. Excuse me. So, it looks a lot like solving equations, and then we've got the graphing. And graphing is different from equations. So let's not wait any longer, let's go ahead and start. Okay, first of all, what's the point of an inequality? Well, it's a practical math concept. Inequalities describe our world. Here's 3 examples. At least 30 kids were at the party. At least. That's an inequality. That's saying it was 30, but it was probably more than 30. You can pay up to 20 days late. It's giving you an ultimatum, a maximum. That's the maximum number of days late that you could pay. The maximum occupancy of the room is 200 people. So again, it's giving you an ultimatum. It's giving you a limit. So the maximum number of people that can go in the room is 200. So these are all inequalities, and we can describe them with an algebraic inequality. Okay, so an inequality is a mathematical sentence where the solution is a range of values rather than a single or fixed value. And we use these symbols, which you should already be familiar with, but let's repeat them. Less than, greater than, less than or equal to, greater than or equal to. So these are our 4 basic inequality symbols. All right, now I want to come back briefly to this slide. So I've duplicated it. And what I want to do is I want us to write an inequality for each of these 3 examples here. And when you're writing an inequality, I want you to remember that there's 2 rules. The first thing you have to ask yourself is can it be equal? That's the first thing you ask yourself. And the second is it more or less? These are the 2 questions you're going to ask yourself in your mind. All right, let's look at this one. There were at least 30 kids at the party. So K and 30 are the 2 sides of our inequality. Now, how do I translate at least? Now, I'm not going to give you a list of these to translate so that you can try to memorize them. That doesn't make any sense. That's what these questions are for. There's not as much memorization in math as someone might lead you to think. All right, so can it be equal? Well, if there were at least 30 kids at the party, could there have been exactly 30 kids at the party? Yes, because the least there could be is 30. So the can it be equal in this case is a yes, so we put the or equal to line. The is it more or less question. Well, if there were at least 30, what was it more likely that there were? 31 or 29? 31. Because it's at least. So that's a greater than or equal to. Try the next one. You can pay up to 20 days late. All right? Up to 20. So can you pay 20 days late exactly? Yep, because it's up to. But you can't pay any less or more. You can't pay any more than 20 days late, so it must be less. Last one of these. The maximum occupancy of the room is 200 people. And again, that's a lot like pay up to. Could it be exactly 200? Are you allowed to have 200 in there? Sure, because that's the maximum. But you're really supposed to have less. So it just so happened these were all ones that we would translate with or equal to's, but we'll practice more with translating in the classroom. All right, the graph of an inequality has 2 parts, the circle and the direction of shading. So the graph of an inequality, the point is to give us a visual for what we're talking about, what solution set we're discussing. So I tend to say that you only need basically 3 notches on your number line. You're going to put the number from the inequality in the middle, and then count down by 1, count up by 1. Now, obviously, be careful when you're dealing with negatives. Notice the counting, notice the numbering goes further to the negative, so the quote larger, unquote, so larger absolute value numbers are to the left. Whoops, did not mean to do that. Let's fix that right up. There we go. Okay, anyway, we'll switch colors here. So the circle part of our graph is going to be on the number that's in our inequality. And in this case, that's negative 7. But because mine actually, this first inequality here has or equal to, we're going to fill it in. It's like you're shading in the -7. And then we're saying whatever's greater than that as well. So mine tend to look like this. And then darken in that arrow to show which direction you are pointing in. Same idea. Let's do this one. If you're like, I remember this must have come, then pause it, graph it yourself, and then check your answer for me. So again, -7 in the middle, -8 is one smaller, -6 is one larger. This time it's a circle on the -7, but it is not closed because it is not including the -7. See, this includes the -7. That's what the or equal to means. This doesn't. And then that's less than, so we'll shade to the left, shading in all the numbers that are smaller than -7. And you'll notice that -7 itself is not included. Okay, so two parts to the graph, circle and shading. Solving an inequality. Well, you're going to solve just like you would an equation. An inequality and an equation are solved the same way. The only difference is that, or the only couple of differences here are that instead of using the solution to check the inequality, use a number from the solution set. And we'll see an example of that in a few moments. The other exception, the other difference between inequalities and equations, when you multiply or divide both sides of an inequality by a negative, you have to flip the inequality symbol. Multiplying or dividing by a negative flips the meaning of the symbol, flips the meaning of the signs. Let's give you a reason why real quick so that we understand. We know 1 is less than 2, obviously, duh. So if I go through this and I say, all right, I'm going to take my 1 is less than 2 and I'm going to multiply both sides by -1. Well, we've seen that multiplying by -1 switches the signs of the two numbers. And now I want you to look at this. Now this symbol right here is no longer correct. It is now wrong because -1 is not less than -2. So multiplying by that negative reverses the meaning of the inequality so that I have to reverse the direction of the inequality symbol. So when you are multiplying by that negative, it's like reversing the meaning of a sentence. I want to go to the party. I do not want to go to the party. So in each case, they're opposites, and that not put in there reverses that meaning, kind of like multiplying by this -1, right? And that works whether you're multiplying or dividing. So remember, multiply or divide by that negative, got to flip the symbol around. Let's just do a couple of single step or one step inequalities here. All right, so we've got number 1, x plus 15 is greater than 8. It's a one-step inequality. We're going to solve it just like we would an equation. So in this problem, I'm going to subtract 15. So we get x is greater than 7, -7, excuse me. That's just like one of the inequalities we had before. Well, actually, almost, because it was an or equal to. And then graph it. Put your -7, -8, -6 on the sides, open circle, shaded up. So this gives you a quick reference for looking at what answers are working for that particular inequality. So in this problem, we can now say, what numbers are in the solution set? Well, -6 is in the solution set because it's shaded in. So let's check our answer with a -6. -6 plus 15, is that greater than 8? 9 greater than 8? Yes, it is. So that's what I meant by checking the inequality with a number that's from the solution set, not the number in the inequality, because this inequality says x is greater than -7. It does not say x equals -7. Therefore, we're not talking about -7 here. We're talking about numbers bigger than that. So I got to use a number bigger than that to check it. Let's look at the next one. -6n is greater than or equal to 24. And we're going to divide to solve. We're going to divide by -6, which means I've got to remember to flip my symbol around. Now remember, once I do my graph, so -4, oh, that doesn't look like a 4. Okay, let's try that again. There we go. -5, -3 on this side. Closed circle, shaded down for less than -4. So now I take a number from my solution set, and again I'm going to use -5 because that's shaded in, and we check it. -6 times -5, plugging in the -5 for n. Is that greater than or equal to 24? Well, it's 30, and it is greater than 24, which works because it's greater than or equal to. There we go. Check. Okay. Look at number 3. 11 is less than d minus 15. Well, we're going to add 15 to each side. That gives me 26 is less than d, or d is greater than 26. Now be careful when your inequality has the variable on the right hand, or the left hand, the right hand side. Had to think for a minute about which one's left and which one's right. Be careful when your inequality has the variable on the right hand side, because when you are graphing, you will have to think a little bit more carefully about which way to shade. So let's put our 26 in the middle. 25 is one less, 27 is one more. So this is open circle on 26 because it's not or equal to, and its d is actually greater than 26. So we are shading to the right. Now the reason I point that out again, to be careful about the variable being on the, quote, wrong side, unquote. Look, x is greater than -7, it points you in the direction to shade, greater than to the right. Less than, and is less than or equal to -4, it points you downwards. This one doesn't do that. So you might want to make it a rule to rewrite your inequalities with the variable on the left-hand side. Let's test it out. Let's take 27. Is 11 less than 27 minus 15? Well, 11 is less than 12, so yes, that one works. Last problem on this list, and I am kind of hamstrung for space here, so I'm going to do something a little bit out of the ordinary. I think I've done this in a video or two before. Just so happens I can make my space if I don't have it in this app. Okay, on this one, we're multiplying to solve. Now, just because I see a negative on the right-hand side does not mean that I need to flip a symbol. I did not multiply by a negative. I multiplied by a +7 to get rid of this divided by +7. So watch yourself there. Don't flip the symbol just because there's a negative involved. We did not multiply or divide both sides, therefore, no reason to flip. There's my number line. Closed circle on -14. Shaded down. Now this is a unique one because I am not going to use -15 to check this. I am going to use -21. Can you think of a reason why I would use -21? Well, first of all, -15 over 7 is not going to be a whole number, or an integer, I should say, not a whole number, but an integer. And -21 is. And -3 is indeed less than -12. It's a very strange Apple radio selection that just came on the study channel. That's better. And we're done checking that problem. So they are now all done and checked. So we solve, we graph, and we check. Okay, look at some multi-step ones. All right, so pause it and solve them, and then graph them. And we'll take a quick look at the solutions afterwards. And I'm going to write my work out now. All right, so 2 steps here. We're going to reverse the addition or subtraction first. So I'm going to get 3x is less than or equal to 30. I'm going to divide second. So I'm going to get x is less than or equal to 10. My graph is going to have 9, 10, and 11 on it. Closed circle, shaded to the left. And when we check that, let's plug in 9. 3 times 9 minus 5. Is that less than or equal to 25? So 27 minus 5 is 22, which is definitely less than 25. So it fits the less than or equal to. On this one, same start, +5 + 5. -3x is less than or equal to 30. And then divide by -3, which means as soon as I put that negative down there, I've got to flip my symbol around. And I need, how did my x end up a less than sign? There we go. I need to think about that as I'm solving the equation, because if I don't think about it in the moment, I'm going to forget to flip. But it's all right if you do forget here and there, because you're going to be able to check your solution. There's my graph, closed circle, shaded to the right. Now, if I had not done that correctly, I would have ended up with a graph with the -10 where it shaded downward. Okay, that's a terrible drawing. Let's try that again. If I had not flipped my symbol, I would have ended up with a graph that was going the wrong direction, that was shaded to the left. So let's look at what would happen if I then plugged in to check with an erroneous number, like -11, for example. -3 times -11 minus 5. Is that less than or equal to 25? Oh, 5, not 4. 33 minus 5 is 28, which is indeed not less than. It is not less than. So this number would be wrong, and I would have to come back down here and recognize what happened. Now, I did not make a mistake. I did the correct graph. So let's actually check it with the correct type of number from our solution set. -3, and again, number that's shaded, so let's use -9, minus 5. So that's 27 minus 5 is 22, which is indeed less than 25, so I know I did this right. So it's solve and graph and check. You now see the differences between this and what we're doing with equations. I hope you enjoyed our video on inequalities. There's lots of inequalities practice on your practice platforms, IXL and Khan Academy. I'll help you find it if you need it. Just ask. I'll see you guys in class.